Alright, the purpose of this video is to run through a little bit of what we've been talking about with mean and standard deviation. And I also want to give you another example of each, and then an example also of seeing what happens when we change all of the data in a particular way. And then in addition, looking at how to do these with frequencies involved as well. So you'll notice here I'm working in Excel just to make some of the mathematics a little faster. I don't expect you to know how to use Excel, but it is a handy tool for doing lots of calculations fast. So, but you'll see all the math going on, just not the individual calculations. So you see here I have some data, and what we want to do, our final goal here is to find the mean and standard deviation of this data. Okay. Now, of course, finding the mean is pretty easy. We're going to add up all these and divide by how many there are. All right. So I'm going to add them all up. So that's and I'm going to divide by how many there are. Okay. Don't worry about the formulas here. But here I get a mean of 14.875 for all this data. Okay, so if you remember what we talked about when we were talking about variance, this formula right here is the formula for our variance. And if you remember, the variance is the mean. So notice we're adding a bunch of stuff up and dividing by how many there are. Okay, if we wanted to say how many there are, I'll go ahead and put that here. Oops. Okay, so there's 8 different scores here. So we're finding the mean, so we're going to add up a bunch of stuff and divide it by 8 in this case. So what are we adding up? We're going to take each individual score, subtract it from the mean, or subtract the mean from it, it doesn't matter, because we're going to square it. So we're finding the mean of the squared differences of each score from the mean. Alright, so you might remember we used this little table here. So we're going to take each of these scores and we're going to subtract it from the mean. So we have that down in Excel, okay, minus the score, or I guess to match what's up at the top of the row, we should have the score minus the mean. Again, it doesn't matter because these numbers really we're not going to use them, because if you remember, if we found them all and we added them up, they would always add up to 0, because the mean is a center based on distance. So all these distances, the negative would be distances to the left and the positives are distances to the right. If I added up the negatives and I added up the positives, they would end up being opposite, so they'd all add up to 0. Okay? So what we end up having to do is we need to take those and we need to square them all. Okay? So we're squaring them all. Alright, so you can see here Excel is nice for doing this fast. Alright, so now what we have to do is our variance was finding the mean of those. Okay, these are the squared differences from the mean, so now I need to add those up. I need to add these up. I get 148.88, and I need to divide them then by 8. So I need to divide this by the 8. And I get a variance of 18.609 and so on. Now, as we said before, this by itself is not particularly useful. But remember to find the standard deviation, which is our average distance from the mean for each score, we're going to take the square root of our variance. Okay, so there we have our standard deviation. Notice these are pretty spread out. They're not really tightly grouped around our mean of 14.875. So it makes sense that our standard deviation is 4.3. It's not real small. Okay, so that's just a quick example to review how we find this in the first place. Now, one thing that I'm going to do here is I'm going to copy this over. Change that. To this. Okay. All right. So now what I'm going to do is these numbers are going to change in a second, but I want to modify our data. Okay. I want to take a look at what happens when we change all of the data in a particular way. So let's say instead of 14, I actually did 14 minus 3. Okay, and instead of 10, I did 10 minus 3, and so on. I subtracted 3 from all of my original data. Okay, so here's the modified data where I am subtracting 3. Okay, now, again, I need to find the mean of those. There's still 8 scores. Okay, and actually Excel uses average. Okay, so I'm going to find the mean of these, and I get 11.875. And what do you know? Our mean actually ended up decreasing by 3. Okay. Now, the nice thing about this is I can redo this real quickly. So here I'm doing the x minus the mean for each of these scores. I'm squaring those values. And then for my variance, I need to find the mean of those squared differences from the mean. And notice my variance is 18.61. If I got the decimals out, notice it's exactly the same as what I have over here. Okay? Therefore, if I take the square root of that, again, I'm going to get 4.3138 and so on. Okay? I'll bring these both down. Okay? So we see here when I subtract 3 from everything, all of my data, it decreases the mean, but my variance and standard deviation stayed the same. Okay? Now let's see what happens, say, if we were to add 3. Okay, so notice instead of subtracting 3, I'm going to add, let's say add 13. Okay, I'm not just going to add 3, I'm going to add 13. Alright, and I'm going to do that to all of my data. So notice all of these, 19 plus 13 is 32, 22 plus 13 is 35, and so on. Alright, notice what happens. My variance and my standard deviation are still identical, but now my mean, instead of being 14.875, it's 27.875. So again, it increased by 13. Alright, so as a general rule, what we can come up with here is when we add or subtract the same value to or from, depending on what we're doing, from all of our data, the mean will change in the same way, while the standard deviation, and by extension the variance, stays the same. Okay? So let me do this so you can see it. Okay. There we go. So there's our rule. When we add or subtract the same value to or from all of our data, the mean will change in the same way while the standard deviation stays the same. Okay? I want to consider another idea here. What happens if we multiply or divide all the data by the same value? What's going to happen to the mean? And what's going to happen to my standard deviation? Okay, so let's explore that. Let's say that let's multiply all of our data by 13. Okay, or maybe let's start with a smaller number. Let's multiply all the data by 2 first. Okay, so here instead of adding 13 to both sides to everything, I'm going to simply multiply all of my data by 2. Okay, so my new mean is 29.75, and what do you know? If I take 14.875 and I multiply that by 2, I got 29.75. Okay? And notice my variance has now changed. My standard deviation has now changed. And if you notice, it doesn't apply to the variance, but my standard deviation is multiplied by 2 as well. Okay? If I round that to 2 decimals, I'd get 8.63. Okay? So, what if we were to instead, say, divide by 5? Let's say we divided all of our data by 5. We're going to get a bunch of decimals in here, and that's okay. So I'm going to divide everything by 5 now. And let's see what happens here. Our mean was 14.875, but let's see. If I divide it by 5, what do you know? I get 2.975. And again, my standard deviation has changed. It's gotten smaller this time since I divided. And notice it ends up being divided by 5 from what it originally was as well. So the rule we can come up with here is that when we multiply or divide all the data by the same value, the mean and the standard deviation will also be multiplied or divided by that value. Okay? So these are just some general rules here that we can come up with. Okay? So now let's consider what happens if we have frequencies involved. Okay? We have done this a little bit with the mean. We haven't done an example of this with the variance and standard deviation yet, though. Okay? So if you might remember, when we found the mean, what we did first is we multiplied each score by its frequency. Okay? So I had to multiply 14 by 3. That's because there are 3 14s. Okay? So I multiplied it by its frequency. Okay? I multiplied the 10 by 2 and the 17 by 4 and so on for all of these data. Okay? Now, I also needed to understand that there were a total, the sum of all of the frequencies was the total number of scores. So in this case, I have 24 scores. Okay, so to find my mean, I've taken each score times its frequency, rather than writing 14 plus 14 plus 14 plus 10 plus 10 plus 17 plus 17 and so on. You get the idea. I multiplied, so now I'm going to add all those up. I'm going to add all these up, and I'm going to divide by the sum of the frequencies, because that's how many scores there are. And notice here, this ended up becoming 14.875. Okay. Now, if you recall, when we were doing our variance, okay, I took each score and subtracted it from the mean, or vice versa, and then squared it. And then I had to add all those up. I had to find the mean of all of those, okay? So what we're actually going to do here is I'm going to take this score and I'm going to subtract the mean that I found over here, okay? Sorry. Now notice I haven't incorporated the frequency yet, all right? But there I subtracted 14 minus the mean, 10 minus the mean, 17 minus the mean, and so on. Then I'm going to square each of those. Okay, so I square each of these. And in the variance, we were finding the mean of these values. However, here's where the frequency comes in. Here's where the frequency comes in. The frequency comes in because there's not just one squared difference of the mean that equals 0.765625. There are actually 3 of these. And there's not just one 23.76, etc. There are 2 of those, okay? So now what we need to do is we need to multiply this x minus the mean squared by the frequency, okay? So we're multiplying by the frequency, okay? So I am taking this times the 3, because there's 3 of them, all right? And I'm going to do this 27.76 times the 2. And so on for all of these scores. Okay? So notice, if I would have found the mean of these, I would have only been finding the mean of 1, 2, 3, 4, 5, 6, 7, 8 different scores. By doing this, now I've accounted for all 24 scores. So if I take, do this so I can see it all. So if I take the mean of those, I'm going to take the total of all these and I'm going to divide it by that 24 again. That's going to give me my variance for this data with the frequencies here. Okay, so there's my variance. Again, I'm going to square root that, and that'll give me my standard deviation of 3.55. Okay, so that's a quick example, again, of using the frequency, and then finally using the frequency to find standard deviation. Again, the key is start the same way, but before you find the mean of these squared differences, remember that those have frequencies as well. So you got to find the mean using the frequencies. Okay? Alright, so you should be all set, ready to practice doing some of these on your own.